Hello 701 participants. This is an example Excel coding sheet that you can use to code for your study. As a brief walkthrough, feel free to adapt this in any way when you are beginning to code your studies. But a brief walkthrough, I typically like to have a notes column to the far left. This is where I can jot down some notes to myself as I begin to code. I like to label each study that I'm coding in my meta-analysis and give it a specific ID. I typically will add information related to the author, year, and title, which will help me look back up the article at some point in the future in case I have any questions. This is oftentimes necessary because if you submit your study to a journal, it may be 3 months before you hear back from the journal, at which point you may have forgotten where you stored your studies, or what the study was called, etc. So it's helpful to have some information to help identify it. I do like to distinguish whether or not the study was published or unpublished. This is something we'll talk about later down the road when we start talking about moderating variables as well as publication bias. I do have a column typically where I list the independent variable that is used and the dependent variable that's used. And the coding sheet that I'm showing right now is one that you'd use typically if you're coding for correlations, bivariate correlations, but if you're to use a coding sheet for something like a standardized mean difference, it'd be a very similar coding sheet. Sometimes people will add a category here and call it description of the IV. This is sometimes necessary if you're not entirely sure how you've operationalized the independent variable, and it's something that you might want to look at in case there's a lack of consistency across the studies that you're coding. But if you're looking at a specific measure of a predictor variable, typically this isn't a problem. Same thing for basically a dependent variable. You'll notice here that I've labeled y1, y2, y3. This can be the case, for example, if you're looking at the relationship between a specific predictor variable and various outcomes. You might look at some sort of operationalization of pay and an outcome like job performance or turnover or counterproductive work behaviors would be some common outcome variables that we might look at in business context, particularly in management. And typically with a meta-analysis, we don't often look at multiple independent variables, but certainly I've seen it done numerous times. Then it's also important to code for reliability of a survey measure if that is the independent variable that you're using. There's a specific reason why I label this RXXI and RYY. We'll talk about this when we get to the data analysis point, but this is essentially a coefficient alpha or some measure of reliability, internal consistency for survey items. And so same thing for a dependent variable here. This information isn't always reported depending on your literature area. Some literature areas are not as good as others about taking into consideration reliability. And we'll talk when we get to the data analysis point again why we'd want to code for reliability. But sometimes this information may be missing and we would record not reported. And when we get to the data analysis part, I'll talk to you a little bit more about what we would do in this instance. It's very important to code the sample size, so how many individuals participated in the sample, assuming that we're using an individual level of analysis. You can see here that I have a category here. I typically code individual level of analysis as 1, and for example, you might do a group level of analysis as a 2. It's important to keep track of this so you don't mix up levels of analysis and have individuals mixed in with groups. If we were to say that this was a group, for example, we might put a 2. The sample size might be smaller, so you might say just a sample size of 30 here. Then we put whatever our effect size is. So in this instance, we're using correlations, but this could again also be a standardized mean difference or another type of effect size. Then I think it's also helpful to consider some moderating variables. These are some very common ones. So for example, we might have a measure of X that was done by Smith et al., but there might be another one which is done by Jones et al. And so, for example, we might consider whether or not X does equally well predicting Y when we use Smith's scale versus Jones et al.'s scale. We can look at the type of sample that was used, whether teachers or lawyers or students or accountants or teachers, again, were used. We might also look at the nationality of the sample. and use this as a moderating variable. And again, we'll talk about actually analyzing moderating variables a little bit later when we get to the statistics. A couple of other things I like to point out. You'll notice that when I'm assigning the ID numbers, I do put only one effect size. So in this instance, one correlation per line. I think that's important to avoid confusion. Sometimes you'll see that a study has multiple samples, so different groups. So in this instance, one group might have a sample size of 130, and another sample might have a sample size of 200. And in this instance, actually, the reliabilities would typically be different between the two samples here. But other things might be consistent. But I do like to indicate that with different ID numbers, where I say this is all from the same source, so it gets the ID of 2, but this is 2.1 and this is 2.2, to remind me that these are actually independent samples. These are not the same. Also, as I mentioned in my email, or will mention in my email, it's important to calculate inter-rater reliability. So it's very valuable to code initial sample yourself, and then have a friend, or if you have a co-researcher on the project, have your co-researcher independently code separate from you a small subset of samples, and then you can calculate inter-rater reliability, where basically you look at how many coding decisions there were, what was the number of overlapping decisions in which there was agreement, what was the percentage of this, and then plug that in here, and you would get your Cohen's kappa. Alright, and that's it for coding. It's pretty simple and straightforward. It just takes a lot of time. So, and for example, when I mentioned the notes earlier, so I have here reliability is missing for X, need to impute that. So that's something we'll talk, a little bit about in the future, about how you might use other measures of X and come up with an estimate of what the likely reliability was for X in this study. It's an imputation though, so we'll talk about running the analyses with and without it to see whether or not your imputation is affecting the results. Alright, that's it. Let me know if you have any questions.